Yeah. So I keep like no equations, I promise. Wait for our queen to catch up here. Okay, and I hope things shared online. Is that okay online? No.
Why should I wasn't sharing?
Oh yeah, okay, so I just need to share.
Right.
Yeah, okay. Thanks for your patience, everyone. This talk is mainly around a project that we've been working on. It's a partnership between Leahy MTU, Munster Technological University in Cork, Dr. Wesley Oxich, Dr. Kieran Ryan in MTU, myself in UCC, and we also have some external collaborators, including Cork City and County Council as societal champions, and Eirblade as our industry champion. So what we want to do with the Eirblade project is that we want to kind of address what happens in the middle. When we think about blades at the end of life, they need to be removed from service, and we spent a lot of time researching repurposing as a solution for blades. But how do you bridge the gap? How do you get from something that is often considered as a waste to something that can be made into a new product? There's a lot of work that has to be done in the middle. We have a lot of experience gained over the last few years in this area, but there are still some barriers. And what we've learned from doing this is that more work needs to be done in order to make it smoother, make it easier, to make it more cost effective, and to make it scalable, very importantly. So that's what I hope to show you today with Eirblade. And what Eirblade really is that it's a set of tools that kind of sits in the middle that allows products to be matched to blades when it comes to end of life of wind turbines. This is the overview of the talk. So first of all, I'm going to very briefly just talk about some blade end of life solutions. We've already heard a few, even in the last presentation there from Mitch. We had some recycling solutions and landfill as a solution. The image that you see here is probably one of the most overused images in wind energy. This is from the US. See, it's a blade graveyard where we have blades just being landfill. So I'm going to talk about repurposing, which is the subject really of our work over the last few years, and going to show a couple of examples of how blades can be repurposed into new products, structures, and also then talk about the lessons we've learned from doing that. There are several barriers, things that we had to work very hard to kind of overcome, and these are things that can be made easier. And that's the whole point of Eirblade as a project, is to try to remove those barriers and try and smoothen the flow from end of life of end of first life, where blade leaves service as a wind turbine blade, and the second life where it enters service as a new product. So I'll also introduce the toolkit that we have as part of Eirblade and show how that can be used to support this type of transition. But why repurposing? Well, the kind of philosophy behind repurposing, and this came from our previous work on a project called Rewind, which was a very successful international project that ran for several years. This inverted pyramid that you see on the screen here is waste hierarchy. Most of you have probably seen it before. This is kind of the order of preference in principles of kind of waste management, where the things at the top are the most preferable from an environmental point of view, and then we move down to the bottom. So we can see at the bottom, if we start at the bottom and work up, we see landfill is generally considered the worst. Landfill is kind of an interesting case because, as Mitch said, it's cheap. One interesting thing about landfill is that no CO2 or very little CO2 enters the atmosphere with landfill, so it can be considered as a form of CO2 storage. But from many other perspectives, landfill is undesirable, and particularly in Europe, we've limited landfill capacity in a lot of countries, and we also have high taxes as well to try to discourage the use of landfill. Incineration with energy recovery, mechanical recycling, materials recovery, where we're trying to actually, rather than kind of use blade material shredded as fillers. We're trying to actually take out the fibers or take out the resins through chemical or thermal treatments. Structural repurposing is very near the top of the waste hierarchy. So we're not modifying the physical properties of the blade very much. We may be doing some cutting, sectioning, but not grinding or shredding. And then the very best of all, of course, is source reduction and reuse. And lifetime extension falls into that. So if you can keep the blade in operation as blade, then that's obviously the best solution. That can't go on indefinitely. So at some point, you're going to have to start moving down the hierarchy into other solutions. And for every ton of blade waste that we can save from an incineration, we can potentially save 340 kgs of CO2 emissions. And one 45-meter blade, could be 16 tons. So there's quite a lot of mass of material there. Even though the blades are hollow, so they're very voluminous, but most of that is just air and fillers. But even when you look at mass, there's quite a lot of mass there, and there's quite a lot of material embodied there. So this is really what we're about in this project, is how to move from something on the left, which is some kind of very grubby blades that were in a storage yard in Eirblade in Northern Ireland. And those same blades are pictured here as the Blade Bridge, which is in County Cork. So this was built in 2022, I think now, open to the public about a year or two afterwards. Two LM13 blades, which are the main structural elements of the bridge. And they're basically replacing the steel that would be used in a conventional bridge structure. So I'm kind of going to fast forward through the whole process of how we did that, how a bridge was designed, and the design was led by Kieran Moran and MTU. A lot of very detailed reverse engineering, a lot of very painstaking work on testing in order to provide the evidence base to convince clients. A very receptive client who wanted to have a repurposed structure. But still, we had to provide a lot of evidence because this is an unconventional structure made from unconventional materials. So through working through that process, we learned a lot of lessons. So the first one really is that discovering the data, or more correctly, rediscovering the data, is expensive. So what we had to do was, first of all, we had to find out where we could get some blades, which isn't always straightforward. Blades of the right dimensions, blades with the right structural properties that would match the application. We had to ensure that those blades were of sufficient condition for the proposed structural application. We had to capture the geometry of the blades through 3D LiDAR scanning. And the blade manufacturers have this data. They design the blades, they know the geometry, but blade manufacturers, in our experience, generally don't share blade data. So it all has to be rediscovered at a cost. Then you need to carry out testing in order to infer the structural properties. So, for example, for the blade bridge, one blade was actually tested to destruction in a hydraulic test rig in the MTU structures lab. And then a lot of smaller tests, so burnout tests, burning off the resin, looking at the fiber layup, in order to build a kind of complete model of a structural model. That model that could be used to infer the structural performance of the blade. So very labor intensive, very timely, very expensive work. So how can we kind of streamline that process? If we had to do that for every single blade, it would be prohibitively expensive. Of course, mold blades within a family are generally typical. So we can, if we test one blade, a particular model, aside from manufacturing variability, all the other blades will be reasonably similar. So we've kind of, one of the things that we're trying to do in Eirblade is come up with streamlined inspection and testing protocols that will allow us to make confident predictions about the performance of blades without having to go through the full battery of destructive testing. Our goal really here is to try to centralize the structural data and the geometrical data of the blades in order to avoid duplication of work, and so that we can do that kind of matching between an application and a particular type of blade. Another goal is really that this should enable families of repurposed products that are more mass producible, so not bespoke or one-off, and that can therefore be scaled and achieve scale in the market. Second lesson is that when it comes to just procuring blades, a lot of our talks today have mentioned about how many blades are going to be coming out of service, and we're going to have a disposal issue. But actually, when you need to find blades for a specific purpose, it's sometimes not that easy. You need them at a particular point in space and at a particular time. Those blades may not always be available, especially in a smaller, more isolated market like Ireland. So there can be temporal mismatches in supply and demand. And again, the secret to removing this barrier is to good data, having good data on where all the blades are, when we expect them to be decommissioned, and what their properties are. To some extent, a blade storage may also help, just a small amount of storage where blades can be held for short periods of time to match up applications to blades. The location is very important, and the location is important. One of the main reasons is because of the difficulty of transportation, not just logistics, but also cost. And again, that's very strongly related to the length of the blade section. So if blades are above 14 meters, you start going into higher, more expensive transportation solutions. Also, our philosophy as repurposers is that we believe that trying to keep blades local, it's good practice first of all because it minimizes the transport emissions, but secondly, it keeps the value. So any added value from repurposing, refinishing, any extra work that needs to be done in terms of application is kept local, which we believe makes repurposing a more kind of locally acceptable solution. Whereas, particularly in Ireland, there often is a strong opposition to kind of large centralized waste processing facilities, and particularly around incineration. This one is really about kind of trying to find the value, and costs, of course, are very, very important, but sometimes costs can reduce when a technology is scaled up or when supply chains develop over time and things technically mature. But value, this is a two-sided business, as Andy mentioned earlier. So there are costs, but then there's also value in terms of products. And I like to look at this. It's a little bit maybe misleading, but it just shows you that if you just turn everything into value per ton, obviously furniture is a high value product. Now it's a high cost product as well. There's a lot of cost within making it and designing it. But what it just means really that, if you're going for kind of downcycled materials like aggregates or maybe chopped up fibers that are recovered from kind of chopped up pieces, these are very, very low value in the market. And in fact, one of the problems with trying to recover fibers is that the cost of recovered fibers is more than the value of new fibers on the market. So you'll never, it's very unlikely that you'll ever be able to make that into a commercially viable business unless you're taking gate fees or tipping fees. So it is useful to look at it in this way, but it is also, you have to bear in mind that the input costs are not represented here as well. So how can we make repurposing as a solution easier? So some of the things that we are trying to do in Eirblade is address some of these challenges, which somewhat are perceived, and some of them are actual, and some are a little bit maybe of both. The first thing that we often hear is that repurposing isn't scalable, and that's one of the big focuses of Eirblade, is that trying to capture blade data, centralize it, and also try to kind of generalize it and abstract it through simplified models will help in terms of scalability. The other development that's happening at the moment is that actually there's been some interesting work out of DTU in Denmark showing that even some of the downcycling solutions at current economics are not viable, even at quite large scale. So, for example, even in Denmark, a single blade mechanical recycling facility wouldn't be commercially viable. Now, Denmark is part of continental Europe, so at continental scale, those solutions may work, but it just shows that scalability affects everything, all end-of-life solutions, not just repurposing. I've mentioned reverse engineering testing. These are slow processes and they're costly. And also the fact that there's limited data. You know, when a new model of blade is taken out of service, there's not much known about it because the manufacturer doesn't share the information. So that's where Eirblade comes in. We're addressing this through building a repository of blades, and it's referred to as the National Repository of Decommissioned Blades, but actually it's just a National Repository of blades, blades that are yet to be decommissioned. So that's allowing this kind of prediction of flows of blades at end of life to be made more accuracy. We're also looking at condition rating and inspection protocols. So this is when a blade is taken down by a decommissioner, rapid inspection that can be done with no specialized tools, just initially infer the condition. This can help with streamlining blades and making quick decisions on which ones are suitable for structural applications, or probably more importantly, which ones are not suitable for structural applications, and then those can be diverted into either other repurposed products or into other types of waste streams. And one of the important parts of the Eirblade platform is to report on the emission savings, so calculating the life cycle impacts of using repurposing as an end-of-life strategy for dealing with blades versus the alternatives, and also reporting on circularity metrics, so how much material is kept in use through repurposing, or indeed through any other end-of-life solution. So I'd like to just kind of very quickly show an overview of those three tools. Now they're all part of the Eirblade system. So we have a blade level wind energy database in Ireland. The database knows where every blade is, well, nearly every blade, and a projected decommissioning date. We also have been capturing the geometry and structural data of different blade types, and we're aiming to try to build up the coverage of the fleet by capturing the most commonly installed turbines. So over time, we can make the database representative of the majority of the installed fleet. And the idea then is that a designer can come and query the database for a particular location and a particular search radius, particular length, which might be related to an application for a structure, maybe it's a bridge span, and a predicted decommissioning year, so when they need the blade, and then it will return a set of locations that match the search criteria. So through this, we hope that we can kind of do that middle piece, which is matching up the supply to demand, which has been challenging. This can also be used by asset owners to just explore what the potential is of repurposing in their local area. The second one, and this is a mock-up, but we actually have a kind of a production prototype now on the tool of the blade inspection system. It's very similar to any kind of inspection systems that are used for in civil engineering for buildings or bridges or structures. It involves a visual survey. We kind of section the blade into different sections. So we have root sections, transition zones, mid sections, aerodynamic sections, and then we also by the other dimension, so going around the profile from leading edge, trailing edge, and the two high pressure, low pressure sides, and visual inspection where we capture the presence of damage, and then this is all entered into an app, and then that's sent back to the database and essentially stored. So every blade has a unique tag, and then the condition is captured in the database of every blade. And over time, this is how, by using these kind of simplified inspection protocols, we can build up confidence on which blades are suitable for which applications. The next tool is the lifecycle analysis tool, which Mitra has been working on. So this is looking at informing reporting, which there's a demand from asset owners to know, to report on their environmental performance. So rather than just treating blades as something kind of a waste that needs to just be eliminated at the lowest possible cost, we found that pretty much every operator wants to take a socially and environmentally responsible route to dispose it. So by doing this detailed analysis where we look at a particular repurposing use case, so for example, transforming a blade into a blade pole, which will be installed at a specific location, that data can be fed into this tool. It knows the blade material composition, it knows, it all can make assumptions about the processing, the cutting, any refinishing that's needed, and the material and energy inputs, and the emissions associated with transport. And then we can come up with an overall environmental assessment, right down to the emissions associated with that use case and other impact metrics, including circularity metrics. And those can be used then to compare different options, which can be very useful from the asset owner's perspective, and not just a repurposer's perspective. So people coming from either side of the value chain. So that's just a very quick tour of what Eirblade is and what it can offer. It's online, so you can actually you can go on it. Some of the functions you need to register, but the tools are there as prototypes, and we're working on developing them into production versions at the moment. Our next steps really in Eirblade are to kind of increase our data holdings of different blade types so that we capture more blade data and then we get better coverage of the fleet. We're rolling out the platform to designers and decommissioners to try and just road test it, get some more feedback on how we can improve it, make it more responsive to what the users need from it. And what I'd really like to see in the long term is to try to move to a kind of a scenario-based decommissioning system where someone can have a whole set of different options that they would like to consider, and the platform will report back to them on all of them, and then they can kind of make a comparison based on where they are, what type of blades they have, maybe where the repurposing facility is located, and make an informed choice about what to do. So I said I promised to keep it short to the end of the day, but I'll be available afterwards. If anyone wants to have a little look at the platform, we can load it. It's online. We can demonstrate it to you. Just like to thank all the contributors to the project so far. This is funded through a system called the National Challenge Fund through Research Ireland, and our next big test in that is that we have a pitch to an expert panel in October. If we get to that stage, we've already made it through 3 competitive stages with this project, so we've actually been very successful to date. This is the last one. So we basically get another big piece of research funding to try to really push this out into the commercial environment if you get this last stage. So please check out the platform Eirblade.ie, and we're very interested to hear feedback from anybody who would like to explore it. Bear in mind there are still some gaps, but we're working on making it as complete and as useful as possible. Okay, so thank you very much.